Hello everyone. This is a demo of my evolution simulation I created as my final project for Fundamentals of Game Engine Design. My goal was to model evolutionary processes in a small ecosystem populated by AI actors with different physical and behavioral traits affecting how they interact with each other in their environment. The main components of the ecosystem are plants, predators, shelters, and actors. Plants produce apples, which actors must consume to gain energy and prevent starvation. Predators patrol near plants and detect and chase actors in front of them, potentially grabbing and killing them. Shelters provide a safe space for actors to hide at night and allow two actors with sufficient energy to reproduce. Actors have three physical traits: size, which affects their ability to defend against predators; speed, which is their movement speed; and sense, which affects the distance around them that they can sense food, predators, and other actors. Actors gradually lose energy based on their physical traits, with size draining the most energy, followed by speed, then sense. Physical traits are inherited as the average of their parents' traits, plus a potential mutation factor. Actors also have behavioral traits from three gene pairs: social or solitary, brave or cautious, and generous or selfish. Social actors like to move and gather in groups, while solitary actors like to stay alone. Brave actors will attempt to rescue other actors that have been grabbed by predators, and will get closer to predators that aren't actively threatening them. Cautious actors will not rescue grabbed actors and will avoid predators at all costs. Generous actors will share food with nearby hungry actors, while selfish actors will not. These gene pairs follow Mendelian genetics, so one allele is inherited from each parent for each trait, and a single dominant allele will make the trait present. Now that the basics of the simulation are clear, let's look at some of the settings. You have the world settings. You're going to find the simulation speed, the length of the day and the night, and the threshold for when day changes to evening. You can also change how the map is generated. You can change how many actors you have, how the initial actors are spawned, how much energy each trait costs, how actors evolve, how much energy is required, and how often and how strong the mutations are. You can define how they wander around the map. You can define how they gather food and how they share with each other. You can define how they respond to predators. And you can view different actors. You just pick one here. Oh, it's hard to tell which one we're looking at. Here we go. So this actor, you can see that it is seeking shelter. You can see its energy, how many apples it's carrying, all of its stats, all of its genes. You can mess with the plant settings too. You can change the initial population, how many apples they're going to spawn per day, how much energy each apple is going to give the actors, and you can just change the shelter amount. As for predators, you can control how many there are, how quickly they move, the length of their detection cone, the width of their detection cone, how long they pause while they're patrolling, and how long the timer is when they grab an actor before they kill them. The simulation will also log different stats over time. So let's go ahead and unpause the simulation, running at 50 times speed. Here is the graph of the population over time. There's also a graph of the average speed over time, the average size over time, average sense, social versus solitary actors, brave versus cautious actors, and generous versus selfish actors. Now, with the simulation at 100 times speed, let's look at some long-term trends. So I let the simulation run for about 1,000 days. Let's look at the results. Looks like the population has trended downward. Speed has gone way up. It's probably a little bit too overpowered with these settings, but luckily you can modify the energy cost for it to hopefully balance that out. It looks like size has fluctuated a bit. It's been going up recently. Sense has gone up a bit. And it looks like the actors stayed mostly solitary, but social actors took over for a brief period here. Looks like about 40 days they were dominating. It looks like mostly brave actors dominated, with a brief spike of cautious actors. And it looks like, yeah, selfish actors definitely had the advantage.